Okay, so let's discuss question number 38. We have mixture of H2SO4 and H2C2O4, right? Then dot H2, which meaning we have uh, this oxalic acid and sulfuric acid. 25 milliliter of this solution requires 35.5 milliliter of N by 10 H2O. Sorry, N by 10 NaOH for neutralization. So while doing neutralization, right, what will happen? Both of these will react, correct? Neutralization. First case. Second, you're doing oxidation with KMnO4. So when you're doing oxidation with KMnO4, only the only thing that can get oxidized is C2O4 or C2O4 minus or H2C2O4, right? So out of H2SO4 plus H2C2O4, let's suppose if I add KMnO4, since this is acid, what will happen is only this will undergo oxidation. This will not undergo oxidation. Okay. So this is second case. And we need to find out normality of H2C2O4 and H2SO4 and strength of H2C2O4 and H2SO4. So I think by strength, we can express strength in mass percentage. Let's say we can do it in mass percentage. It will be easier. Can do it in volume. We can't do it because we don't have the density part of it. So we'll do it in the mass percentage. Okay. Or we can do mass per volume because the total volume is given and mass we can find out. Anyway, so the first case, neutralization, right? We know NH2SO4, right? Then volume is how much? We have 25 milliliter plus NH2C2O4. This is complete neutralization. So we can assume that the H2C2O4 also fully dissociated and fully neutralized, right? 25 milliliter should be equal to what is the molarity? Sorry, normality of NaOH 1 by 10 multiplied by 35.5. Correct? Okay. So you get NH2SO4 plus NH2C2O4 will be equal to 35.5 divided by 250. Okay. So this will be the normality, addition of normality. So keep this as equation 3, right? We'll come back to this, right? Next case, you have second case. Your second case, oxidation. So H2C2O4 plus MnO4 minus sense of H plus. It's an acidic solution anyway. We have Mn2 plus CO2. Correct. I'm not balancing or anything. We know the n factor is 2, n factor is 5. Anyway, so equivalence of H2C2O4 should be equal to equivalence of KMnO4. Correct. Equivalence of KMnO4 is, if we check, it is 23.45 into 1 by 10, right? So 23.45 multiplied by 1 by 10 milli equivalents, right? The volume that we have is 25. So 25, sorry. 25 milliliter multiplied by normality of H2C2O4. So what will be the normality? Normality of H2C2O4 will be 23.45 divided by 25 into 10. Correct? So you get 23.45 by 250 normal. Correct? Now this is equation 4. So applying, so already got the normality of H2C2O4. Applying 4 in 3, you get NH2SO4 should be equal to, you have 35.5. So, and all were divided by 250. So 35.5 minus 23.45 divided by 250. What will this be? This will be 0.05 to 12.05 by 2. Okay. Since it's a subjective question, we can keep it this way, or you can further do it, right? We can further divide and give the answer. But I'll stop it here. But I mean, from here it's just calculation. Now we have to find the strength, correct? So how do you find the strength? So normality is given, right? So weight of H2C2O4 in 25 milliliter is, how much is it? We know weight. So we need to find the so this is, what is the molecular weight of H2C2O4? We have 24 plus, so weight of H2C2O4, correct? How much will you get? You'll get 90. So this molecular weight is 90, correct? 64 plus 24. You'll get 88 plus 2, 90. Okay. So 90 multiplied by number of moles of um, H2C2O4, right? So norma not normality, sorry. Yeah, normality of H2C2O4 multiplied by volume divided by n factor, correct? Because this will give me the number of moles. So how much is that? So that will be 90 multiplied by, you have 23.45, right? 23.45 divided by 250. Okay. Multiplied by 25 by 1000, right? Milliliter. Multiplied by, one factor is, sorry, not multiplied. Divided by, one factor is 2. Correct? So this get cut. Okay. So, and this get cut again. So you will get, how much will you get? So you have 9 multiplied by 23.45 divided by 2. So you'll get around, okay. So 9 multiplied by 23.45, right? Divided by 2 divided by 100, correct? So you'll get around 1.055 gram. Okay, this is H2C2O4. Now, what about weight of H2SO4 in 25 milliliter? Correct. Here the molecular weight is 98. So you can do the same thing. 98 multiplied by, you have 35, sorry, 12, right? It is also, yeah, 12.05. 12.05 divided by 250 multiplied by 25 divided by 1000. Again, uh, and factor of H2SO4 is 2. Okay. So, yeah, what will we get here? Again, 25 get cancelled, right? So you will have 98 multiplied by 12.05, right? Divided by 10,000 divided by 2, correct? Okay, sorry, here the answer will be 0.1055 gram. Okay, here the answer will be 0.05959 gram. Okay, so if you find percentage weight by volume of H2C2O4 will be 0.1055 divided by 25. So you'll get then multiplied by 100. So you'll get 0.4 percentage weight by volume H2C2O4. Then percentage weight by volume of H2SO4 will be, you have 0.059 divided by 25 multiplied by 100, correct? So you'll get 0.236 percentage weight by volume H2SO4. So we found both percentage weight by volume and normality. Normality, I didn't finish the calculation. You can finish the calculation and write the value, right? Anyway, there won't be any subjective question in JEE. So you can look into the option and figure out where should you round your answers to. Okay.